Hey, Mr. Richards here. Today's Algebra 186 practice. Factoring polynomials and leading to equations. In the notes, we reviewed a method to do this that involves factoring by grouping using the Xbox method. And so as we go through some of these examples today, the the coefficient with the variable, we're going to call our A. The coefficient with the variable that doesn't have the exponent, we're going to call our B. And the constant, we're going to call our C. And so as we go through, A here is 1, and that's going to be the case with all these problems on this lesson. Our B is 4, and our C is a negative 45. And so with this Xbox, we're looking for a product of A and C, which is negative 45. So we're looking for a product of negative 45 that adds up to be a sum of B, which is 4. And so you start to think of things that multiply together to be 45, and that would be something like 9 and 5. And if you were to use, say, negative 5 times 9, that does together multiply to be negative 45, and negative 5 plus 9 does add up to be a positive 4. And so we're really looking here at negative 5 and positive 9. Now, the reason for this box is just a little side note here. Essentially what we've done is we've taken this t squared and this minus 45, which is why we then take the t squared, put it in here, and the minus 45, and put them in the bottom right. What we've done by finding this negative 5 and 9, we're replacing the 4t with a minus 5t and a plus 9t. 4t becomes negative 5t plus 9t. And that's what we're putting in these boxes, a negative 5t and a 9t. And basically what we're doing with this is factoring by grouping. Because as I look here, my greatest common factor is a t. My greatest common factor here is a 9. Coming back across, it's still a t. And here it's a minus 9. And so I can write my solution here, my factored answer, as t plus 9 times t minus 5. Or, I'm not going to write this every single time, t minus 5 times t plus 9 is also the same answer. Now, if we remember back to our last lesson where we did factoring by grouping, what things we did was that, okay, we're going to put parentheses around this and around this. We're going to try to find a greatest common factor here. Well, in this one, it would be t, and we're left with t minus 5. Here, it would be a 9, and we're left with a t minus 5 again. And if you look here, here is the t plus 9 being pulled out, which is exactly what this part was. And on the inside here was our t minus 9. And so all this Xbox method is doing is it's kind of giving us a graphical way of doing this factoring by grouping. And I just had a little typo there. That's not typo, but writing O. That's t minus 5 there. But all our Xbox method is doing is really factoring by grouping, but just in a graphical way. And so we're going to focus on this Xbox method the rest of this assignment. So as we go to factor this polynomial, our A is equal to 1, our B is negative 16, and our C is 63. And so A times C is 1 times 63 to be 63, and our B is negative 16. And so we're looking for a product of 63 that adds up to be negative 16. And so you start thinking about 63, I'm thinking 9 times 7. That's a positive 63, but when I add 9 plus 7, that gets me to a positive 16. But a positive times a positive is a positive, but so is a negative times a negative. Negative 9 times negative 7. That is a positive 63, as is negative 9 plus negative 7 is a negative 16. So there they are, negative 9 and negative 7. And so we put in our d squared and our 63. We put in a negative 9d and a negative 7d. And now we try to pull out the greatest common factors. And so we have d, and in this one it's minus 7. This is a d. Here it's a minus 9. Means we are left with d minus 7 times d minus 9. Moving on. Here, our a is 1, our b is negative 1, and our c is negative 56. Our a times c is 1 times negative 56, which is negative 56. Our b is negative 1. So we're looking for a product of negative 56 that adds up to be negative 1. And I kind of lock in on 8 times 7 here. 8 times 7 is 56. But obviously 8 plus 7 is not negative 1, it's 15. But if I'm looking for negative 1, try negative 8 times a positive 7. That's a product of the negative 56 we're looking for. And negative 8 plus 7 is the sum of negative 1 we're looking for. And so the negative 8 and the 7, negative 8 times 7 is negative 56. Negative 8 plus 7 is negative 1. And so as we substitute these in, we have our q squared and our minus 56. And then we can put in our negative 8q and then our positive 7q. So we look to find the greatest common factors in these rows and columns. We have a q, a positive 7, a q, and a negative 8. And so this one turns out to be q plus 7 times q minus 8. (15) Now, if it's helpful to rewrite this as r squared plus 18r plus 32, then do that, because remember the coefficient with the squared variable is always our a, so that's going to be 1. Our b is 18 and our c is 32. Don't get confused because this is written in a not standard form. So a times c is 1 times 32, which is 32. Our b is 18. And so we're looking for a product of 32 that adds up to be 18. And so probably looking at positive numbers, probably looking at a number that's kind of, I don't know. You have things like, let's think here, 4 times 8 is 32, but 4 plus 8 is 12, and that's not 18. If we think about 16 times 2 then, that is 32, and 16 plus 2 does equal 18, so there they are, 16 and 2. As 16 times 2 is 32, and 16 plus 2 is 18. So we can now substitute things in. We have our r squared in the top left, our 32 in the bottom right, and the two other things we just found, 2r and 16r. Greatest common factor here, you have an r with a 16. Here we have an r with a 2. And so r plus 16 times r plus 2 is our solution. One last factoring. A little bit different because we have a j squared and a jk and a k. And so let's go through it. We're going to have our a equal to 1. Our b is equal to -9. And our c, let's just make equal to -10. Let's solve it like we normally would to start. We have -10 as our AC, -9 as our b. Product of a times c, that equals -9. Let's try -10 times 1. That'll be that -10 we're looking for. And -10 plus 1 is going to be the -9 that we're looking for. And so we have -10 and 1 coming out here. We have j squared, and we have a -10k squared. Now, if we go back to what we're actually doing here, we're trying to come up with a different way to factor by grouping, a visual way. And so if you're wondering, well, what's going in the other two boxes? This was j squared minus our 10k squared, and all we've done is replace this -9jk with a -10jk plus 1jk. And so that's what we're putting in here. A -10jk with a 1jk. And so as we factor this thing out, it's going to look a little bit like it normally has. Here, it's going to be a j. Here, I'm looking at a k. Here, I'm again looking at a j. Here, I'm looking at a -10, looks like a k. So what does that mean, as crazy as this looks? J plus k times j minus 10k should be our answer. Now, any of these, if you don't feel comfortable with the answer, could you go back and check? Sure. If you look at j plus k times j minus 10k and undo this, if I multiply this one out, I would get j squared minus 10jk, and then the k would be plus 1jk minus 10k squared. And look, that's exactly what we had there. You combine these two things and you have j squared minus 9jk minus 10k squared. So with any of these, you can always go back and re-multiply it out to see if your factored answer is correct. And now we get to actually solving the equations. We're going to solve them the similar way here as we were factoring. We have to first factor this though. And so our a is 1, our b is 17, and our c is 42. So a times c is 42, b is 17, so we're looking for a product of 42. That adds up to be 17. Well, if you jump to 6 times 7, that is 42, but 6 plus 7 is only 13, so that's clearly not going to be it. Another one you can think about, well, what about 21 and 2? Well, that's not going to work because, yes, that's 42, but 21 plus 2 is going to be 23. And so then we get to something like, let's see, 42 can break into 2 and 21, and 3 and 7. What if we did the 3 with the 2 and the 7? 2 times 7 is 14. See how I kind of use the factoring there to find factors that could possibly work? 3 times 14 is 42. 3 plus 14 is 17. There they are, 3 and 14. And so we have x squared and 42. We have 3x and we have 14x. Get the factors out. You have an x and a 14. You have an x and a 3. And so what we've been getting to when we're just factoring was just x plus 14 then times x plus 3, and we're calling it good. The difference now is we're solving equations. And so this is going to equal 0 now. And just like when you have a times b equals 0, either a or b has to be 0, we're going to say, well, we could have x plus 14 equals 0, or the x plus 3 equals 0. And again, I guess you really don't need the parentheses there. I'll go ahead and get rid of those. Subtract 14, you get x equals negative 14. Subtract 3, and you get x equals negative 3. And those are our solutions, negative 14 or negative 3. Checking. Go back to the original to check. Our original was x squared plus 17x plus 42 equals 0. And so on one hand, you would have negative 14 squared plus 17 times negative 14 plus 42 equals 0. On the other hand, you would have negative 3 squared plus 17 times negative 3 plus 42 equals 0. And you would solve these things down, and on this side you'd get 0 equals 0, and of course you'd get 0 equals 0 here. In this question, A is 1, B is 3, C is negative 54. So we're looking for A times C is negative 54, B is 3. So we're looking for a product of negative 54 that turns out to be 3 as a sum. Well, if we look at a positive 9 and a negative 6, that multiplies to be negative 54. And 9 plus negative 6 also turns out to be negative 54. I'm nuts. No, it doesn't. What am I thinking? It turns out to be 3. Hello. Yikes. Sorry about that. So, we have 9 and negative 6. So we have our k squared, our negative 54. You have a 9k, and you have a negative 6k. Get your greatest common factors out of here. K minus 6 and k with the 9. And so you have your equation now. K minus 6 times k plus 9 equals 0. Split the equations now. X minus 6 equals 0. I'm sorry, k minus 6 equals 0. And k plus 9 equals 0. So k is going to equal 6. K is going to equal negative 9. And so you can write it like that. Sometimes you'll see it written like negative 9, 6, like this. Either way, you get your solution. And to check it again, go back to the original. And so k squared plus 3k minus 54 equals 0. So on the one hand, you have negative 9 squared plus 3 times negative 9 minus 54 equaling 0. So 81 minus 27 minus 54 equaling 0, which you get out to be 0 equals 0. On the other hand, we would have 6 squared plus 3 times 6 minus 54 equals 0. So 36 plus 18 minus 54 would have to equal 0, and it does. 0 will equal 0. So negative 9 and 6 are our solutions. 3 more to go. In this type of equation, you have to be careful because these always have to be set equal to 0. And so we first need to start off by actually subtracting 32 from both sides of this equation. So that way we can make this equation equal 0. You're going to equal 0. So that way that cancels. You're left with n squared plus 4n minus 32 equals 0. And so now this way our a is 1, our b is 4, and our c is negative 32. A times c is negative 32. B is 4, so we're looking for a product of negative 32 that adds up to be 4. How about a positive 8 times negative 4? That does multiply to be negative 32, and 8 plus 4 does equal, 8 plus negative 4 does equal a positive 4, and so 8 and negative 4 are our factors here. We have n squared, a minus 32. We have an 8n and a negative 4n. Pull out your greatest common factors, n, negative 4, n, positive 8. And so n minus 4 times n plus 8 are going to equal 0. So either n minus 4 has to equal 0, or n plus 8 has to equal 0. Add 4 to both sides, n equals 4. Subtract 8 from both sides, and n equals negative 8. So you have negative 8 and 4 as your solutions here. Checking, restart with the original. So n squared plus 4n equals 32. Start with the negative 8. Negative 8 squared plus 4 times negative 8 has to equal 32. So a positive, because negative 8 times negative 8 is a positive 64. Minus 32 has to equal 32, and yes, 32 does equal 32. So that checks out for the negative 8. Put in the 4. 4 squared plus 4 times 4 has to equal 32. 16 plus 16 needs to equal 32, and of course it does. 32 equals 32, so the 4 checks out. Like our last question in 23, we need to make sure we're having this thing equal 0 to begin with, so subtract 56 from both sides of this equation. This way that cancels out. You're left with t squared minus 26t minus 56 equals 0. A is 1, B is negative 26, which is a big B, and C is negative 56. And so A times C is negative 56. B is negative 26. We're looking for a product now of negative 56 that adds up to be negative 26. That must mean these factors are going to have to be, the factors are going to have to be pretty far apart in order to be able to add up to negative 26. And so, obviously not as big as 56 times negative 1, right? Because that is negative 56. But when you take 56 plus negative 1, you're still sitting at 55. And even if you flipped that, still, the fact is they're 55 apart. But you're not going to get that much different, all right? With this, again, this b being so big, you have to look for numbers that are far apart that are being multiplied. And so then if you go to 2, for example, negative 28 times 2 equals negative 56. And guess what? negative 28 plus 2 does equal negative 26. So my hint to you, if you're still watching and listening, is the further apart that, or the bigger this number is here, the further apart your numbers being multiplied have to be. If this number is small, then that means those numbers being multiplied are close to each other. And the more you solve these, the more you'll just start to see that. We're looking at negative 28 and 2. Negative 28 times 2 was the negative 56. Negative 28 plus 2 was the negative 26. Put in your t squared. Put in your negative 56. You're splitting these to negative 28t and 2t. Take out the greatest common factor. 2t. I think I reversed those in my head. t, 2, and then t and a negative 28. We have then t plus 2 times t minus 28 is going to equal 0. So either t plus 2 equals 0 or t minus 28 equals 0. Subtract the 2, t equals negative 2. Add the 28, t equals 28. And so you're looking at answers of negative 2 and a positive 28. And I'm sure by this point, some of you are seeing kind of a pattern and going, well, this is a lot of work just to get to negative 2 and 28. Why are we doing this? Why is a always 1 and we're just setting it up this way? In our next lesson, this coefficient with the exponent term will start to be things other than 1. And so to get into this routine of practicing, just kind of trust me as we go through this. It will pay off in the end, even though it's just a little bit more work now. When this term starts to be a 3 or a 4, understanding this process and this flow will pay off at that point. To check it, let's go back to the original. So t squared minus 26t equals 56. And so we'll start with the negative 2. So negative 2 squared minus 26 times negative 2 needs to equal 56. This is 4 plus 52 needs to equal 56, and it does. You put in the 28, and so you'd end up with 28 squared minus 26 times 28, and that's going to equal 56. And I'm just going to trust that we're right on this one and say 56 equals 56. All right, sound good? Let's get to the last question, 27. Same kind of thing. We need to make sure this equals 0. So we're going to subtract 5y from both sides here. So our equation then is really y squared minus 5y minus 84 equals 0. So our a is 1, our b is negative 5, our c is negative 84. A times c at negative 84, our b is negative 5. So again, we're looking for a product that's negative 84, but a sum that's only negative 5. And again, when the sum is kind of small, that means these things that are getting multiplied need to be pretty close together, in all honesty. And so, again, the strategy is if you're looking and struggling with this, so let's look at negative 84, or just even positive 84. And if I were to make a factor tree of this, if I divided this in half, I certainly have 2 times 42 to be 84. But, you add those things up and it's going to be nowhere close to negative 5. So what if I split this again and get 2 and 21? Well, now I have 4 times 21, but that's not really going to help me. So what if I split this again and get 3 and 7? So I'm looking at maybe 2 times 3 is 6, times 2 is 12. I'm just looking at these three. There's a 12, and here's a 7. Because remember, 84 is 2 times 2 times 3 times 7. And so if you're really looking here for how can I get this to be only added up to 5, or in this case negative 5, use a factor tree to help you group these things. Because then 2 times 2 times 3, like I said, is 12. This is a 7, so 12 times 7 equals 84. That can be a difficult pair to find if you're just trying to find it with the calculator by guessing and checking. But maybe it's possible to use a factor tree to help you find these things. So if 12 times 7 is 84, and I'm trying to get to -5, let's call that 12 the negative portion. So -12 times 7 is that -84, and -12 plus 7 is -5. And so -12 and +7 are what we're looking for here. Tough to find, but maybe the factor tree can help. So we have our y squared, our -84, our -12y, and our +7y. You pull out the y, you have a y and a 7, a y and a -12. So y plus 7 times y minus 12 is going to equal 0. And so y plus 7 could equal 0, or y minus 12 could equal 0. Subtract the 7, you get y equals -7. Add the 12, you get y equals 12. And so your answer is -7 and +12. And for the last time in this lesson, we could check these. And I'll at least give you the outline for this. As you could tell, I'm without my calculator on this today, but give you some of the foundations for how to solve this at least. When you put in -7, that would be -7 squared minus 84 equals 5 times -7. -7 squared is a +49. Minus 84 would need to equal a -35, and you subtract these out and you get -35 equals -35. So -7 is a solution. When you put in 12, 12 squared minus 84 needs to equal 5 times 12. 12 squared is 144. Minus 84 needs to equal 60. And sure enough, 60 equals 60, so 12 is a legitimate, good solution. That's it for this practice assignment. There were a lot of work here, a lot of questions to solve, and it seems like a lot of details, and it might seem like a lot of work and a lot of repetition. But again, in the next lesson, we're going to be dealing with some concepts that are a little bit more complicated. And so having this strategy down, which is really just a graphical way of factor by grouping, hopefully will help in the long term. So that's it. I hope this is helpful. Feel free to email me with any questions that you might have. Good luck.